right? Proving triangles are congruent. Okay, now we're going to move into relationships that happen inside a triangle, or maybe two triangles. So it's going to be kind of vocab heavy and kind of a lot of info, but we'll manage. Okay? So today's all about bisectors. What do we know about a bisector? Cuts it in half, right? So it can either be an angle being cut in half or a side, right? Okay, so let's just see what happens here. Maybe. Okay. Perpendicular bisector. Okay, when you hear the word perpendicular, what are you thinking? 90 degree, yep. And bisector, so cuts it in half. Read this little thing to yourself, and then we'll talk about it. Try to understand it, and then we'll do it together. Read the little sentence. We'll go from there. So it says, if a point lies on the perpendicular bisector of a segment, then is equidistant from the endpoints of the segment. So let's just break this picture apart. What is our segment in this picture?
CD. No. CDB.
AB is our segment. Because what is CD acting as?
The
Perpendicular bisector. Because right angle, and they're telling me this guy is equal to this guy. It's
Oh,
okay.
that makes sense. And then AC equals CB.
So then Glenn says AC is equal to CB?
I just looked at the other one and it said AC and it's backwards.
Well, you're right, because it says if I have a point on this perpendicular bisector, it's equidistant, which means what? The same distance from the endpoints of that segment. So AC is congruent to CB. Okay, what does converse mean?
Opposite, backwards.
Flip the order. So it's the same thing, we're just flipping the order. So if I know that AC is congruent to CB, what other things do I know?
AD is equal to DB.
Okay, that's one thing. AD is congruent to DB. What else?
AC and CB. Or no, CD is perpendicular to AB.
Yep, and then I would know that this guy's perpendicular. Remember that upside down T is our shortcut for perpendicular. So I always think words are confusing in math, but when we try it on some problems, I think it will make more sense with some numbers. Says find the value of x. So let's just first look at a few things. Is this segment here perpendicular to this one?
Yes.
Yep. And then is it bisecting that side over there? Yeah, right? Those tick marks are telling me that. So what's an equation I can do to find x?
7x plus 24 equals 13x minus 48.
Yep. Because I know this endpoint here is equidistant from those sides. Perfect. And do a little math. I know what x is. I got 15. What did you get?
It's probably 15.
Probably, yeah.
I got. Let's see if you're
Oh,
Yeah.
I didn't know what it was.
Did you guys get 12 though?
Yes.
That's sincere.
Sure.
Yeah, okay. Good job.
That's a big number.
Okay, what about this guy? What can I do?
17x minus 3 equals 9x plus 13.
Yeah. Kind of when in doubt this chapter, guys, if they look equal, just set them equal to each other. Like, if you have no idea, that would be where I'd go.
That's what I did last year.
That's what you did last year?
No, last chapter.
Oh, last chapter?
Yeah. I kind of run on when in doubt.
I just rolled.
Yeah, x equals 4.
Did you?
I got 2.
I got
I got 2.
No way.
I got 27. X equals 6. I'll be in the office.
Okay, now we have some relationships that happen when I have perpendicular bisectors in a triangle. So, the perpendicular bisectors of the triangle intersect at a point called the circumcenter, which is this point right here.
Wow.
And then there's some properties that go along with this. The circumcenter is always equidistant from the vertices of the triangle. So it's equal distance away from those corners of your triangle. So let's answer some of these questions here. List the perpendicular bisectors. What would they be? So your hint is, if you're looking for something that's perpendicular,
Yeah.
BC.
BC.
PE.
BC. Yeah. Would BC work? 'Cause, like,
So this
Yeah,
to me means a right angle, right? So where are my little boxes at?
Yeah.
DE, PE, PF.
There's one. There's one. There's
So
one.
basically everywhere that's not a corner.
Not necessarily. DP, PE, and PF. What's our circumcenter? P.
Oh my gosh.
Then it says list all the congruent segments. There's a lot going on here.
That's a couple.
So let's just start with A, and we'll just work our way around the triangle. So one tick mark AD matches what?
DB.
DB. That's a good one. Okay. BE has 3 tick marks, so what does that match?
EC.
EC. And then I have CF is congruent to what?
FA.
Beautiful. Is there anything else that's congruent?
No. Wait.
No.
Wouldn't there be PB is congruent to? Wait. No. Yeah, PB and PC are they congruent?
Yeah.
And
It says the
PA.
circumcenter is equidistant from the vertices. So,
Oh, and then PB and PA.
yep, all of these green guys are also equal.
Would
Wow.
P, D, P, E, and PF be equal? No, because
Nope.
PF is way shorter.
Right, those ones aren't equal. But PB is congruent to PC and AP. Told you there's a lot going on.
Wow.
Wow.
It says if Z is the circumcenter of a triangle TUV, find each missing measure. How about before we even look what we're trying to find, let's just go around and list everything we know.
Okay.
Because that seems like a better idea.
T, Z, and ZU are both 21.
So he's saying TZ is also 21 because of this guy. Do you guys agree? And same with that one. So 21, 21. What would VY be?
Half of 34.
Yeah, because I'm going to split it in half. So what's half of 34? 17. 17.
Isn't ZU 21?
Z.
Oh yeah, you already got that.
Oh, did we get that? Okay.
I just missed it.
What about, can we find TX?
Yeah, it's 19.
Yep, so if this half's 19, I know that this guy's 19. Yep. That's a good start. Let's see what we're trying to find. Okay, TU would be what?
38.
Yep, because I'm adding these guys together.
VY.
BY, where is BY? This, so 17. UZ. UZ, where are you? UZ would be
21.
21.
Oh,
WV, where's WV at?
no, that was not 21.
How would you know that?
What angle's right here?
90.
Oh,
So what can we? What theorem can we use?
Oh, that's their.
Oh wow.
wide angle side.
What kind of a triangle is this guy?
Alright.
Right.
Right.
And the base is. Okay. No, but not.
I was never.
Right? Pythagorean theorem never goes away.
A squared plus B squared.
So this is my hypotenuse, and I'm looking for one of my legs.
Why do you have 15?
That's what this is.
Oh.
Parallel line.
Oh no.
Alright, figure out what x is.
Wow.
I have a question.
There's a few proofs. Proofs don't go away.
Do they in algebra too?
Is it 6? No. Proofs is just kind of like a geometry thing.
Oh.
14.2.
Like 14.69.
Sure.
I would say he's just fine.
Can I get a second on that?
Can you like walk us through it?
I sure can.
You don't have to do this.
May or may not have forgotten.
That's alright. Okay, what's 15 squared?
It's a square root.
220 something.
The square root of 260. 14.7.
What's 21 squared? 4
And
something.
then you'd have to
441.
469 after that, actually.
Okay.
Okay, so 6,
9.
What's 441 minus 225?
216.
216. What's the square root of 216?
14.7.
14.6969.
Gosh, you 14.69.
9. 14.69.
It doesn't say to round up though.
You need to spell all.
You do what you want.
I'm putting
Well,
14.
you're welcome.
Okay.
I'm saying I'm throwing down 14.69. But is that just because we're right down 16? No.
Takashi.
He's
TV.
locked up.
Where's,
Whatever.
okay, what would TV be, folks?
29.4.
Because what do you have to do to this guy?
Double it.
Double it. 29.4.
Actually, I'm right on 77 is my favorite one.
Okay, so in a nutshell, that's kind of the gist of perpendicular bisectors. Kind of a lot, isn't it?
Yes.
Okay, let's move on
It's a
to
little much.
an angle bisector.
Probably like 11.
No, there's no time. I got busy this morning. It's not long.
No, but like, especially on this, especially like,
Okay,
Jersey numbers,
read this
like,
blurb.
11 looks so gross on the jersey.
For Jersey, mine's 17.
Glenn,
That's what.
Logan, read this to yourself. See what happens.
Alright.
Read it.
That's my favorite. I just roasted.
What?
I just roasted.
What'd you say? Let me hear it.
BD. Well, that's just because I read the next question.
Context clues. That's the thing.
Learn it when you're in elementary school. What'd you say, Christy?
Okay, let's read it together. It says, if a point on a bisector of an angle, that doesn't make sense. If a point is on the bisector of an angle, then the point is equidistant from the sides of the angle. So let's look. Here's my big angle, right? And here's my angle bisector. And D's on that point. So now what do I know?
The other two are equal.
What's
CD
equal?
and DB are equal.
Yeah. CD is congruent to BD.
Okay.
Okay, then the converse is also true. So what would we write?
For that one, would you write AD bisects angle BAC?
Did you guys hear Glenn?
No.
Because he was right. Glenn, will you repeat yourself?
AD bisects angle BAC.
Yep.
Blood alcohol content.
What?
Sub BAC.
What else would we know then? If AD is bisecting angle BAC.
Angle BAD is equal to CAD.
Yeah. I'm gonna write that too.
Oh, I guess I'm
Okay, you guys try that next problem with the numbers. The example.
It's the same as you said, right?
It's kind of like myself. It's kind of my rules now.
What are you doing?
It doesn't matter. I can scribble it and later. After I wrote like the same two pairs.
Equals 15.5.
Yeah. That's
Lucky number 7?
yeah.
Yeah.
All right.
You get 7.
How
did you get 15 and a half?
I got
Yeah, I'll check it.
6.
I didn't get 15 and a half.
Do you have the right signs,
That's what I said.
Sophie? Like the right symbols?
I'm trying to figure out what I did.
Because 9 minus 4 is 5.
Oh, see, I didn't do that. I did that. There was a 9x, I put 7x.
See, that's
So
okay.
therefore, I get 3x equals
Yeah.
7, which that's 9 equals 7.
But now we know. Now we know.
Oh, that's still
Okay, try this one. What do you know about those angles?
Those are the best little writing on the
3x equals 60. Not 60, 50.
How would you get 50? Because you would add.
I'm so tired.
Oh, that's a negative.
Yeah.
That's
Negative or straight B?
What's
Yeah, I'm not doing it that way. You do the other way.
so then
So then x equals 10.
Did we get 10?
Yes.
No, Michael?
Yes.
Yes? Oh, you're funny.
Uh,
Okay, and then we have something called the in-center, right?
yeah.
Yep. And that's when all your angle bisectors intersect inside your triangle. And then there's a list of properties that go along with this as well. The big one being that the in-center is always equidistant from the sides of your triangle. So let's label some stuff here. List all your angle bisectors. So, what do we think?
P, P, C, and P.
So I'm going to go to my angle, right? That's cutting that one in half, cutting that one in half,
True.
and that one. AP, BP, and CP. What's our in-center? P. Okay, and then what are all of our congruent segments?
PE, PE, PF.
You guys agree? That's this part right here?
Yep.
Yep, good work. So DP is congruent to PE, which is congruent to PF. Beautiful.
Can we say that the two side ones are equal? Or
Can
yeah,
you
do they
give
still
me?
bisect? Yeah. So
Like
then
which ones?
DE and like GC.
D.
DE.
Or not DE. That's B on top.
DB and B.
Or no, like BE and EC.
Well, that's not true, but there is another one that's true. FC is congruent to EC. AF is congruent to AD. And then BE is congruent to DB. So it's like these guys are equal, those guys are equal, and the top two. And I gotta write all that out. Okay. DB is congruent to Alright, let's try this last example. It says, if P is the incenter of triangle JKL, find each missing measure. How about we go around again and fill out what we know?
Okay.
What else do we know?
And K is 17.
Agreed. Because this guy is equal to this guy,
NP and PO are 8.
right? Because the incenter is equidistant from your sides. And that might be it for now. Okay, so we said NP is 8. NK is 17. PK 13. You want to say 13?
That's
Because
way
this
more.
one's 13. But what do we have to do though? Pythagorean theorem, because this is a right angle. So 8 squared plus 17 squared equals x squared. Someone help me, what's 17 squared off the top of your head?
289.
289. 289 plus 64 is
18.
353.
square root of 353.
18.8.
Oh, that's what you're saying. Thanks, Glenn.
It's actually 18.78.
What about LO?
Well, then we do the same thing.
We have to do the Pythagorean theorem again. But this time, this is my hypotenuse, so it'd be 8 squared plus x squared equals 13 squared.
You destroyed my room. I'll put the works on you. Oh, yeah?
Oh, Mason, you really got him there. Destroyed his career. Sorry.
10.2-ish?
Yeah.
Okay. I'm going to have you do a few problems on